All right, trigonometry. Okay, everyone should be doing this. Just go somewhere else. No, I don't care. You came in late, you're playing on your phone, you still haven't taken stuff out, just go. Smudge, go. Wherever you were whenever you came in late. Maybe you can hang out there. Go. All right, double angle identities. Double angle. Double means twice, right? Twice whatever the angle is. Okay, so double angle 15 would be 30. Okay, is that something we know? Yeah. This works out all the time. Every time. So, on this problem right here, you could do it for the cosine formula, and then you could actually go through and solve for either thing. So we have 3 different formulas for cosine. We only have one for sine, though. We only have one for sine, so it comes out like this. So the double for sine works out because I have this and this, which are the same. Add them together, I get 2 times that. Tangent comes out to here. Okay. This is the one that you're actually going to be using all the time. All the time. Every time. Every day. All day long. Just like that noise. Cosine theta is 3 over 5. We know cosine is what and what? Cosine is what over what? X over? X is 3, R is 5. Now, I gotta find a y value. Pythagorean Theorem. And this next part right here says that sine theta has to be less than 0. So it's negative. We have done this problem so many times. You should look at it and tell me, hey, what's the y value? 4. It's negative 4, right? It's negative 4 because y has to be negative. You guys have done the Pythagorean Theorem that many times. So, Pythagorean Theorem, it's going to be, for this one, it's 3 squared plus y squared equals 5 squared. 9 plus y squared. 16. So, let's take a look. So, given this information right here, we're going to find sine 2 theta. So, I just need to pick one of the formulas. Okay, I'm just going to pick a formula for it. So, I only have one formula for the sine 2 theta. So, sine 2 theta is going to be 2 cosine theta sine theta, right? 2 sine theta cosine theta, right? Yeah? Good. So, 2. What is cosine of theta going to be?
Negative 4 over 5.
3 over 5. What is sine theta going to be?
Negative 4 over 5.
What do I do with those numbers? Multiply. So we get, let me see, negative 12, negative 24. So this one is my sine 2 theta. Yes?
Yeah.
Okay, so there's that one. What's next?
Cosine.
Cosine 2 theta. So I just need to pick one and find it, right? Let's do it. So I'm going to erase. So cosine of 2 theta. I could pick any one of those problems that I want. Okay? Any one of those formulas. So it could be, let's do this one right here. 1 minus 2 sine squared. So, on the right-hand side, it's going to be 1 minus 2 times. What is sine? What was sine?
4 or 5 over
4 or 5, right? So it's negative 4 over 5 squared. X going at first, right? So it's going to be negative 2 times 16 over 25. And then this is going to be, so 1 minus that. But I'm going to make my 1 funny. Do I need common denominator? What is my common denominator? 25, right? Common denominator is going to be 25. So this is going to be 25 over 25 minus 32 over 25. Negative 7 over 25.
Can't we also plug it into the calculator so that way we don't have to keep doing it every time?
What do you mean?
They can do a calculator.
You can do this part in the calculator, but the problem is, if you end up with a radical, you're going to end up with nasty radicals and end up having to redo the whole thing anyway. So radicals are going to come up all the time. All right, so the tan 2 theta. So I could use the formula for tan. So tan 2 theta is going to be 2 tan over 1 minus tan squared. Was it 2 tan? Yeah.
Oh, this is super easy.
Okay. So for my fraction, it's going to be 2 times tangents what over what? Y over x. My y value is? My x value is? Over 1 minus. And that's squared, right?
Yeah.
Do the math. So it's going to be negative 8 over 3 all over 1. That's going to be minus 16 over 9. So let's clean up that denominator. So what's the common denominator on the denominator? 9, right? So it's 9. So this is going to be 9 over 9 minus 16 over 9, right? Not yet. 9 over 9 minus 16 over 9 is negative 7 over 9. So it's negative 8 over 3 divided by negative 7 over 9. And we cannot have fractions over fractions, can we? Yes. Cannot have fractions over fractions. I have to multiply by the reciprocal. So it's going to be negative 8 over 3 times the reciprocal, which is negative 9 over 7 which is going to give me, cancel 3, cancel, so that's 24 over 7 as my tangent. Okay, it's not bad. It really is not. So if you follow what I've taught you and gone over each time, it's the same thing over and over. X, Y, and R. X, Y, and R. We're applying it. We're plugging in. We're putting things where they go. X, Y, and R. Actually, this goes with the previous one. It's the same one. Same one. All right, here it is. Now, find the 6 trigonometric functions of theta if cosine 2 theta is 4 over 5. All right, on this one right here, because this is cosine, I could use one of those 3. I need to find the 6 trigonometric functions. That means I need to find sine, cosine, tangent, but that's just for those values. And I know that cosine is supposed to be x over r, but it's not the same if it's a double. It's not the same if it's a double. Okay? So, I'm going to plug this into one of my formulas to actually get my values. Alright, so which formula do you want to plug it into? 1 minus sine? Okay, good. So, it's going to be 4 over 5 is equal to 1 minus 2 There we go. So, what I'm doing right there by actually plugging that in where I did, I'm changing a double angle into a single angle. So we're trying to get theta by itself. I'm trying to find what sine theta is supposed to equal. Okay, I'm going to try and find what sine theta is going to be. So from here, I'm going to go through and just isolate so it says sine theta. Then I'm going to do it again. I'm going to say where it's cosine theta. So let's take a look. I'm going to start by subtracting 1 from both sides, right? Minus 1 minus 5 over 5. Give me a second. Let me stop my recording. Yeah. All right. So, what are we going to come up with? We have a positive 4 over 5 and a negative 5 over 5, right? So let's say negative 1 over 5 is equal to negative 2 sine squared theta. Yes? Okay. So now I have that. Say yes.
Yes.
Okay, good. Now I have a place to start. I'm going to divide both sides by negative 2, right? Let's do that. Negative 2.
Just positive 2. Then it's the opposite.
No, it's not opposites. I'm dividing here. So the opposite over here would be the addition and subtraction. But so I'm trying to get something by itself. It's going to be dividing it out. And so I need to divide the whole thing. So 2 negatives make a positive, 2 positives make a positive, right? Okay, so good. So over here, this is going to give me positive 1 over 10 is equal to sine squared theta, right? Yes?
Yeah.
Okay, so given that much information, what do we say to do next?
Square root.
Square root both sides. So now it's going to be sine theta is equal to plus or minus the square root of 1 over 10. Where is my value have to be? What quadrant's that? Quadrant 2, right? Okay, so, but I'm saying sine right now. So we know that sine has to be positive, right? In quadrant 2, sine is positive, right?
Yeah.
So this value has to be positive. So I'm going to rationalize this thing now. I'm going to rationalize this. So it's going to be the square root of 1 over square root of 10. Multiply, so it's going to give me rad 10. So it's going to give me rad 10 over 10. So this is rad 10 over 10 is equal to sine theta. Did I completely foobar and lose everyone? Because he's got both earbuds in, not even trying to look at any of this.
Well,
I got sleepy, I got grumpy, I got dopey. Come on now. Ask, please.
It does like a lot different.
Yes, I already told you guys.
Oh, okay, never mind.
The way that I do this, because you,
Yesterday's down. It's down.
yeah, because we do X, Y, and R. We've been doing X, Y, and R since chapter 1. We keep doing X, Y, and R, X, Y, and R. So why should I teach you something brand spanking new if you already know the X, Y, and R? That's my point that I'm trying to make. Okay, I don't have to go through and actually redo it like that because that would actually be more tedious and it'd be a lot more involved learning a brand new way of doing this. The math is sound. We do X, Y, and R, it always works. Okay? So given that much information right there, okay, I went through and I found that sine theta is equal to rad 10 over 10, right? Yes.
Yeah.
Equal to rad 10 over 10. So now from there, I know that sine is what over what? Sine is y over r, right? So I could say that my y value is rad 10, my r value is 10, and my x value is, I'm not sure yet. But I already have everything laid out to do that. So given x, y, and r, can you solve for x? Okay, I can solve for x now, right? That's just Pythagorean Theorem. So we said that, what's it?
X squared plus y is
So y was rad 10, right?
rad 10.
R is
10.
10, and I'm looking for x, right?
Yeah.
So it's going to be
X squared plus square root of 10 squared plus
10 plus x squared equals 100. So it's going to be minus 10, so x squared is equal to 90. So x equals the plus or minus square root of 90. Ah, that's a 90. So what is 90? How do I get to 90? Say 9 times 10. Why did I use 9 times 10? 9 is a perfect square. 9 is a perfect square, isn't it? Okay, so it's going to be 9 is a perfect square, and that's what I'm factoring out. So 9 times 10. What is the square root of 9? 3. So my x value, yes. My x value is going to be 3 rad 10. But now, what quadrant did we say this is? 2. So it's going to be a quadrant 2. So it's going to be x right here. So it's x is equal to 3. So negative 3 rad 10. So you guys could disregard this part right here because they don't rationalize. They didn't rationalize when they did this. Huh? No, the graph wasn't rationalized. All right, so we need to find the 6 values. Right? Did it say 6 values?
Yeah.
6 values. All right, so I'm going to insert a new one here. Page here. All right, we know sine was rad 10 over 10. Okay, cosine.
3 rad 2. Negative 3 rad 2.
Tangent. What's tangent going to be?
Oh,
So it's negative rad 3. Or I'm sorry, negative 3. No, just rad 10, so right? So it's rad 10, try to do too much in my head, over negative 3 rad 10, right? So what's going to happen to those rad 10s?
cancel out.
C theta. So cosec is the reciprocal of what? So I take sine and do what?
Oh, so 10 over rad 2.
Can I rationalize?
Yeah, rad 2. Then,
So 10 rad 10 over 10, which is just
rad 2.
secant is the reciprocal of
Cosine.
cosine. So I take my cosine and do what?
Okay, 10 over rad, negative 3 rad 2.
Rationalize?
Oh, 10 over 10.
It's going to be negative 10 rad 10 over 30, right?
Yeah.
Okay, what's going to happen to that 10 and 30?
Divide.
It's reduced, right? Negative rad 10 over 3, cotangent. Cotangent, take my tangent and do what? Flip it over. So if it's tangent's negative 1 over 3, my cotangent is negative 3 over 1, or just negative 3. X, Y's, and R's. Every single time. X, Y's, and R's. I was really hoping to not have to redo this lesson, but you know what? It's fine. We got time. This stuff is not easy. It's simple, but there's steps involved. There's steps. X, Y's, and R's, the things that we've been doing all year. It's steps. So as soon as you find your X, Y's, and R's, you can actually come up with all of that information. So we came up with sine was rad 2 over 4 from the warm-up. If you guys remember that? If you do. All right.